All right, well, great. You can go ahead and advance to the next slide. Excellent, we just saw the demonstration video, right? So I'm gonna be touching a little bit about lowering the barriers to enable people to work more efficiently with a lot of the open source tools that we all love and use out there and have been learning about and seeking to take advantage of. So I'm gonna get right into it. So I manage the ROS-Industrial Americas Consortium. You'll notice the little icon on the bottom left, the logo. But I'm based out of Southwest Research Institute. And I won't get into a ton of the background, but here at the Institute, we've been doing a lot in advanced robotics for a number of years, building custom robotic systems, and it was a lot of reinvention of the wheel, right? A lot of for those of you who've done a lot of industrial robotics in the past, it was really hard to port your capabilities from one brand to another, right? So the group here at Southwest Research Institute struggled with a lot of those problems. And another group was using ROS back in 2010. We had a research team member, Sean Edwards, who went out to Willow Garage at the time, working with Motoman or Yaskawa, and paired with them and then created, in collaboration with who is now Open Robotics, the first implementation of a robot driver that could enable an industrial robot to interact with ROS. So that's what our group does. We're here on campus in the Southwest United States. I've been here for some time, and we like to say deep sea to deep space for all the stuff we do. Next slide. So we do a lot of advanced systems, as I elaborated on, and these are just a couple examples in the pictures. But as a lot of the cases we're seeking to do with ROS tool sets, right? We're obviously trying to manage dynamic environments, all the different things that can happen in a factory setting, enable that high mix, low lot scenario. And of course, mobility has become a big thing these days, right? So these are all things that we've leveraged the open source tools and particularly the ROS framework to solve these challenges, right? And in a sense, like obviously support the consortium here in Americas. But this is a little bit about what our group does and how we use the tools to solve problems. These are just a couple examples. Next. Next slide, please. So one of the really exciting things that we've been working with in the context of ROS Industrial, and particularly our consortium model, is that it's really enabled the acceleration of systems into production. And so this example here, we worked with an end user that wanted a prototype to demonstrate capability, but we collaborated with a solution provider, Bastion Solutions. And for them, they were able to take the proof of concept that was built out in ROS and then bring it forward and basically create a product that was based on that prototype in less than a year, right? So the key idea is this enabling foundation, a little bit like the video you saw from before, right? So not, there's these pieces, we can bring them together and we have some place to start at, and that accelerates innovation. Obviously, we're very interested here in the Americas, and I think all of our consortia that support ROS Industrial are interested in finding the right partners, right? Who is it that can create solutions? Do they have the right talent? At the same time, right, there is this need to address and empower end users. And that's definitely something now that we found the right partners, right, now let's think about what we can do to empower end users. And that's one of the exciting things we're looking forward to talk about today. Next. All right, go ahead and step through the animation. Stop there. So one of the things with the advent of ROS2, you've heard Daryl mention ROS2 during his presentation. We're very excited about ROS2 as well, but we couldn't just run off to ROS2 and forget about all those that are still using ROS. So one of the things we've really been thoughtful about, we're trying to take care to, is to focus on what is the real sort of building blocks or the capabilities that make the ROS applications work, that drive the innovative capability, and where possible, build those out as ROS independent libraries. So basically they're pure CMake or C++ libraries, and then provide middleware wrappers to facilitate their interoperability with ROS1 or ROS2, or say a different middleware, whatever yours may be. And then of course we have then interactions with the environment winners. This has enabled us to actually attract more people to consider ROS2, because it's become not an all or nothing game, right? So they don't have to, if they have a good legacy code base, they can either develop new capability in ROS2, potentially have it interop, or we can take a look at some other solutions. They can dip their toe in. They can grab new capability that maybe rolled out initially in ROS2 and backport it to ROS1. So it's given industrial users a little bit more flexibility to not necessarily feel left behind with the growth of ROS2. It's really challenged our team for the open source libraries we maintain and the new capabilities we're putting out. But we believe it's a good service to say like, hey, thanks for not leaving us, and encouraging people to consider ROS2, but knowing they don't have to like today, that there is some runway. So it's been really helpful to our community over here in Americas. We hope it's similar for everyone else around the world. Next. Yeah, go ahead. And so everyone here, mostly you're familiar with the consortia, right? There's a lot of stakeholders that have supported it, but there's two key elements, particularly the vision, right? So we have these 4 pillars that we've been focusing on in recent years. And a couple of them I'm going to touch on today. One of them is the ease of use, right? So as Daryl touched on and you heard about in the video before this, we need to lower the barrier to entry. It can't be someone who's like this unicorn of a master's degree in mechanical engineering and a master's degree in computer science, or heaven forbid, a PhD in computer science to put together capability. And we need to lower that barrier to entry. And that's something, again, a theme we're working on, as well as facilitating interesting new ways for people to interact with systems, as well as looking at more of the whole value stream and interoperability. But today I'm going to be focusing a little bit more on the ease of use side. Next. So this is going to be a sample of some of the recent applications. We've been supporting and deploying systems in a class of applications that we prefer to call scan and plan. And these are just a number of different examples. Now, we've deployed enough of these into production. I would call the enabling libraries to a degree pretty mature. However, when you go to build out the application, there's a lot of nuance and complexity in the building out that application that's pretty unique. But here you can see an example where we enable operators to circle regions they want reworked. That's another form of human-robot interaction. It does lower the barrier as far as being accessible to the system and interacting with it in new ways. But it was actually a very complex system to build. That system was actually all on ROS2. Here, we're basically getting to the point of autonomy and precision sanding. In this particular case, we're having to follow very precise edges and do different surface removing. Now, it has to be set up and managed by people who aren't necessarily very computer savvy, right? So, but it's largely targeting autonomy, right? So that's more advanced capability. This particular application, what we call robotic blending, was probably the beginning of the scan and plan family of applications. Talking a little bit here, we're talking about machine learning informed segmentation. This is actually a weld in this case, but it can be extended to other features. Visual programming, again, here we are trying to enable end users to do something a little bit easier, leveraging common open source tools, including ROS and OpenCV. And here it is doing what we call visual programming. And this was recently open source, so we're very excited to make this available to enable people to more efficiently potentially teach robots to do new things. Inkjet printing, right? So here we're just doing recreating graphics on the sides of vehicles. Laser coding removal, right? So here we're leveraging ROS for localization and navigation. These are just, again, more kind of common scan and plan applications that we leverage, how we leverage these tools in our day-to-day business and help our partners. Next. So I wanted to really focus on this ease of use and the human-robot interaction today, right? I think, Daryl said a lot of the same things, right? We're trying to accelerate adoption, right? So what can we do to help our partners speed up the novel capability development, become self-sufficient, and solve their problems? Be able to enable them to implement their IP, right? So in certain cases, be it visual or augmented reality, or if it's this simpler menus or interfaces, can we enable them to what we call traditional programming with the robot in an efficient way, while breaking down barriers to adoption. Much like the AMD example that was shown in the intermission video, providing tools to enable more people to be basically drive their systems, if you will, have them do new things. Next. So, I grabbed this snapshot of the video for the visual program. It's a great example, but we also created an offline toolpath planner too, because one of the biggest things that, dating back to my time deploying traditional industrial robot systems, we spent a lot of time up front on the system doing all this work offline. but it was basically how you programmed with a teach minute, but just at a computer, at a desk. So we've been working on really creating intuitive ways to create waypoint dense trajectories on surfaces to facilitate different types of processes that to generate in traditional ways is very cumbersome. We have a number of different forms of raster path planners, for instance, all available in this offline toolpath planner, and it's open source and available and going through some overhaul, but it's still a fairly functional tool that we've deployed in a lot of systems and have made it open source and available. Visual programming is the kind of the robot wrangling you kind of see on the right here. It's been recently open sourced. It leverages basically some visual tracking tools that are like basically the tracking tools in the frame of the robot, and with some other cues, you're able to kind of indicate waypoints to facilitate very simple programming. And I'm going to spend a little bit more time on the ROS Workbench because this is a very different way for how we may deploy ROS capability and a very much what we'd like to think a grab and go capability, right? And so I'll spend a little more time on that today. Next. So ROS Workbench, right? I'm going to get into this, right? So we have a node diagram on the left that kind of like lays out a traditional system. But the spirit here is that to allow non-software developers to create more complex systems in ROS. That's what we're trying to do. We run into, I just was in a meeting all day today with a very engaged end user. Their background is sort of mechanical engineering and materials processing, super bright, but they're absolutely lost when you start talking things like CMake or build issues or compiling or dependencies. So even for very bright people that know their processes, know what to do, we have to lower the barrier, have to give them tools if we're really excited about industry adoption, right? So we've taken on a project with some internal, basically both funding on our side as well as some help from some partners, seeing if we can move the ball forward to make setting up systems a little bit more efficient. Next. So this is just an example of taking basically a model-based view. Next. Sorry, I thought I went to the next slide. Great, model-driven programming. This is where I was going. So this is a little bit of an example of, like, say, the difference between Unreal versus Unity. The idea, like when we're doing game programming, it is a little bit more what we call model-driven, where you have function blocks versus, say, it's a scripted language. We find a number of our end users are a little bit more comfortable with this model-based approach to programming. You see it a lot in MATLAB as well. And so we're investigating how far can we take this idea when we're talking about building out ROS-based systems. Next. So we're going to start with a number of different simple editors. We have a couple examples already out here open source. So for instance, the environment editor is actually a proof of concept is available. There's a blog post out on rosindustrial.org is deployed via the Snap store. And I'll touch a little bit on the Snap deployment here in a little bit. But the vision is that we have this myriad of different editors. I believe if you hit advance, it'll bring up another screen. There we go. There's the kinematics editor. Next. A planning pipeline editor. This is actually the command language editor, to be correct. I didn't include screenshots of everyone. Next. This is the toolpath plan editor. So you can see here it's very menu driven. You can put in basically custom design and layout and even interact with your objects to do a toolpath planning. Next. This, I believe, is the execution or runtime HMI application. Yeah. So these are the different examples of some simple editors that basically enable people to be dangerous at minimum and develop fairly sophisticated solutions from different various menus. Next. So one of the things we've been doing is taking a look at the development environment. The early work and the prototype application, the environment editor I described a little bit out there, is actually built on Ignition. We got a lot of pushback from early adopters and testers. They were really thinking, hey, if you're going to do this and enable us to pull in geometry, we'd like you to maintain it in a CAD ecosystem. So I probably can't read it at the top of the font there in that graphic. It says FreeCAD. So we've been evaluating FreeCAD, actually it says it there on the left, creating basically the user screens and a lot of the menus and functionality to interact with the different editors in FreeCAD. This is an example of one of the editors. Thank you. And so the idea is we don't break the chain for the digital thread. And that's the spirit about staying in a CAD environment as opposed to moving over to Ignition. Ignition gives us the better visualization and the physics. However, there is this tie back to the CAD that was requested by some end users. So this is kind of where we're starting. Next. I mentioned a little bit on deployment. So we've already been working a lot with Canonical. Canonical's been a member of ROS-Industrial Americas and a strong supporter. Obviously, they maintain Ubuntu. So they've been a very big advocate of open source and robotics. So they've been really, really helpful, right? So one of the things that we'll be doing is trying to deploy basically via the Snap Store and Windows MSI. X cloud-based deployment as well will hopefully be supported, but we're going to start with these two app stores initially. And one of the candidate applications is our focused technical project, robotic blending. So the goal is we'll actually be working with a couple of solution providers anticipated on the next round of robotic blending, the focused technical project in the consortium. And then we'll actually have these solution providers try to build the core scan and plan application and interact with it and configure it for their hardware via these tools. And so that's what we're going to try to test it on, and we will see. And hopefully it'll come together okay, right? And so, because one of the things that we've learned with a number of our end users, if they don't have an integrator network to work with, their solutions do not really get into the factories. All right, so what can we do to provide tools and features that entice the solution provider community to use these tools? And so that's kind of where we're going. Next. So we've been doing a lot of other work. Hang here, right? So one of the things that we've standardized on and really trying to support and get a little bit more word out is ROS SCXML. There was a time long ago where typically we'd integrate the state machine into the GUI. One, it's kind of, you can just do it in parallel and stitch together all your components, but it does lead to really big challenges from a serviceability. When you start actually going and running on hardware, next thing you know, you've got to make changes to your state machine. ROS SCXML provides a really nice way to make updates. It basically updates an XML file and manages that. Yak Open3D is a new version of our reconstruction tools. For those of you who've used Yak, I think you'll find Open3D to be a more sophisticated and robust solution. We want to support it with that with Intel Labs. Nether's the toolpath planner, and of course some new updates to Tesseract. Next. That's the process planner, and that's the toolpath planning. Doing a lot of work deploying ROS2 into production. You can go ahead into the next slide, sorry. Kind of rattled through. A lot of work in deploying ROS2 into production. We've fielded about 7 systems now, ROS2 based across a number of different projects and supporting them reliably. So there's some references here about some lessons learned, as well as some recent talks on that work. Next. And then finally, we've been working on some collaboration. I think a lot of you by now are familiar with the ROS2 UR driver that Picnic released. So that was an interesting collaboration between consortium members across Americas and EU. So it was pretty exciting. Spirit Aerosystems will actually be speaking Thursday on actually swapping out the bridge with the ROS2 driver and their experience on that. So if you're able to make the time, Thursday US Central Time in the morning, there's a community meeting where they'll be talking that experience. These are a couple different examples of other collaborative projects. A lot of work going on real-time planning, and then some reversioning of Descartes Lite. So if you're a user of Descartes for Cartesian path planning, you may want to check out some of the new stuff coming out relative to Descartes Lite to facilitate more efficient process planning. We'll be releasing some more information about that in the coming weeks. Next. Yeah, and there's okay, finally, the takeaways, right? So hey, we're 10 years strong, right? It's hard to believe that. ROS-Industrial as an open source project is nearly 10 years old. I'd like to think, and I think Daryl touched on this, it is becoming, making a push and supporting how people are thinking about industrial automation. So that's really exciting to be looked at as an expert in how to leverage open source. ROS-Industrial is a resource for both the advanced robotics community and of course the industrial robotics community, and that's been a real great place to grow into. I think we're really starting to make some hay relative to the consideration of ROS2. I know at first, it was like, you will have to steal ROS-1 from me. I will not switch. We're finally kind of reaching the tipping point where we're getting more acceptance around ROS-2, and it's been great to play a role there and educate our partners. And obviously, we're really taking a hard look at ease of use. And hopefully we can provide some tools that are helpful and beneficial to the community. Next. And this is just some summary resources. And so if you're familiar with ROS-Industrial, you know these, I'm sure. And then my name is on the last slide. And I'm sure the organizers will make these slides available. If there's any questions or comments, don't hesitate to reach out.